everyone. Good afternoon, and thank you for joining us for this very quick fireside chat. This fireside chat is titled Agentic AI Meets Quantum. Are we building machines that discover differently? My name is Shivangi Jain. I'm a senior economist and a global modeling lead at Economist Impact. And I'm really pleased to be joined by Wally, chief executive at Strangeworks. Thank you for joining me.
I was pleased until I saw you brought a list of questions.
I don't think we'll get through all of them. We haven't got that much time. But thank you for being here. So I guess just to begin our conversation, Worley, and just to set the scene, we're talking about agentic AI in the context of scientific discovery. Mm-hmm. What potential does it offer beyond sort of existing AI applications?
So there's a lot of projects around this. I don't know if a lot of people have seen Google's co-scientists they're releasing for white papers. There's, 100 little open source projects, another thing. But we're entering this very, very important time. And I think it's really applicable to quantum because quantum computing, still has so much to be learned about quantum mechanics and all of these things. We still have decoherence times that are shorter than the gate times and things of that nature. And I feel like we need AI, we need this assistant research to kind of solve those problems. At the same time, AI is going to create formulations that probably don't run well on classical computers, right? So there's this kind of symbiosis to begin with. The biggest thing, though, is everyone looks at agentic AI and thinks this will be great for repetitive tasks, right? This is how I don't, answer all the mails or I do things. And you see projects, again, like Google's, agent space and stuff that are all focused on these repetitive tasks. And while that's really important, I don't think that's the value of agents, right? I think the value of agents is super complex tasks that I might not be able to do by myself. And so I like the co-scientist approach. And at Strangeworks, what we did is we took and did a survey across all of our customers. Where do they have trouble when they're running the machines? And we found quantum has a cold start problem. And that cold start problem is they don't know what to discover, what to use the machine for. They don't know how to formulate a problem once they do. And then they don't know where to deploy it because one of the big issues with quantum computing and business and kind of them being out of sync is that we talk about quantum computers as if they're computers, right? We say quantum computing. And so in December, you saw Google release their blog on a white paper from August and all the quantum stocks went rising up. And then Jensen walked out on stage and said, 20 years away. And, when I get asked about that, say, look, if you're one of the annealing guys and you say it's been here for 10 years and you're Jensen and you say it's 20 years away, or you're DARPA and you say things are happening in 12 to 16 months, or you tell me it's 2 to 3 years, those are all correct answers, right? Because a quantum computer, a bit is a bit is a bit, but a qubit is maybe an annealing bit or a superconducting bit or a neutral atom or whatever. And so, customers are very confused, and this is where this agent model has really come into play so that they can use their internal resources, suck them into a system, have them evaluated, and then say, these are the areas you should use it. And here's the way we can formulate those problems for you. And then here's how we can help you write that code and deploy it out to those different machines that also all use different, types of coding schemes and things like that. So I think, agent technology will dramatically improve the adoption of quantum computing.
Right. That makes sense. And as you said, there is no kind of fixed timeline to this. There are things that are continuously evolving. What would you say are kind of the most immediate applications that you can kind of see in the shorter term? And what are the limitations to building that out longer term?
So, I think, that cold start problem is a really big focus for us because we want to see more people using more of the machines that all of the vendors out in the lobby do. We want to see drive more adoption. Past adoption, there's just the area of science. We're here, and what's the closest football team? Is it Manchester,
I'm the
Chelsea?
wrong person.
I'm the wrong. There's several here. So, which one? Arsenal. All right, great. So let's take Arsenal. Let's see. There's clearly people who don't agree with you, but that's okay. If you guys were the loudest, I'm going with you. So let's take Arsenal. So let's take the key to your flat. And let's imagine every researcher, every funding of science, everything. And let's put that in the perspective of the world's problems. We lost trillions of dollars in the pandemic. Okay? 1 in 6 deaths is caused by cancer. We used 640 gigajoules of energy last year. We have no idea of how to create more energy or more abundance of energy. We've got disease and Africa, on the continent of Africa, the ability to produce crops has been reduced by 34%. So we've got problems across the board that are scientific by nature.
Right.
But that key represents all of science. And if we went to Arsenal's field and we threw that key in the middle of the pitch would represent all of humanity, and that key would represent the 0.1% of people even remotely involved in the scientific process. And so the biggest thing that will happen is the evolution of science. I gave a talk in Dubai called From Playgrounds to Particle Physics, and where I argued that children aren't the future of science, they're the now of science, because they're curious, because they ask why, because they question things, because they don't know. So you look at something like what we're doing or what Google's doing and these different projects, and you think about having this kind of co-collaborator that has a resource you can't even fathom of all this knowledge in the world and understands that contextually. And you pair that with, curiosity and this natural thing that kids do. And all of a sudden, you get this vision of the future where a 13-year-old girl wins a Nobel Prize because she saw something because it affected her in her life. So imagine how different the world would be if instead of 8 million people involved in science, there was 1 billion people, right? Or 2 billion or 3 billion people. And there's arguments, there'll be all these bad ideas and all that, but it doesn't matter. Like the law of large numbers, we will make more progress as a species. And so the big role of agents, both in quantum and in science in general, is unlocking this kind of walled garden and allowing everybody to be able to participate in this process somehow. And I think that will get better and better and better. I mean, I do see a superintelligence future. I've talked about that since, 2018 when we started the company. But I think, the in-between now and then is the ability for more people to have more creative ideas in science, not just in the arts and everything that we think of creative thinkers, but creative thinkers driving scientific discovery. And I think that's probably the biggest thing that this technology is going to unlock.
That's a really interesting, incredible even vision of the future that you've just set out. Just thinking about how we actually get there. What are the sort of are there any technological limitations that we face at the moment, and how does quantum enable some of that?
Well, I think that a lot of those problems are intractable by nature. And because they're intractable problems, I think this is where quantum computers play a big role in it, right? So that's not to say that you couldn't have a supercomputer of GPUs or things that wouldn't solve some of them. But I think the really, really interesting ones require things like simulation, right? Require digital twins of the real world. And I think this is where, the limitations of CPU and GPUs, memory size and everything, if you're going to build a model of some of these things versus we've got 100 qubits or 200 qubits or something, we can actually model it one for one. That's where I think it really overlaps and really generates some very interesting, ideas about what could be done, and everything from computational chemistry to drug discovery to all these things that we often talk about in the industry.
Yeah, very interesting. What about if we think about some of the risks of these technologies? What are the kinds of safeguards that we might need to be putting into place just on ethical grounds?
I've received many emails from AI ethics people in the last few years, which are probably more qualified.
A summary of that email.
They're probably more qualified to ask. Look, technology is a sword, and it has two edges, right? And when you think about it, initially I kind of break that little bit of fear and uncertainty and doubt you're bringing into three categories. Initially, like LLMs are great at a lot of stuff. There's also hallucinations. There's also all of that stuff. So clearly we need to clean that up, right? The second kind of category would be like, there are limitations. I mean, they will have sucked in all of the knowledge that we have very soon. And then all of a sudden, the only way for them to grow in intelligence will be synthetic data, right? So there's a kind of how do we stop the hallucinations? How do we build the synthetic data? On the outer edge of that, right, is this, the one that everybody wants to worry about, which is the bad actors, right? Like, okay, well, if you're creating this science for this, how come somebody doesn't make an aerosol that kills only a certain type of people in a room at the Economist event, right? And those are serious, real concerns. And those are concerns that I think are technological by nature that we often look at as policy concerns. And so because of that, we need to get the technologists and the people writing the policies closer in relations on how we address those. So maybe there should be some limits on what you could do. Maybe we should take those bad ideas and program it into an agent that says, I can kind of see where you're going there. That sounds like you're building. Maybe we won't give you the next step or whatever. So, I kind of look at it in those three phases.
Okay. Interesting. And if you had to say from your perspective, what is the biggest limitation looking forward in terms of driving and scaling up quantum technologies? Is it on the tech side? Is it on these ethical issues that people are raising? Is it more on the policy side? Is it a combination of all of these?
I would take two of those. I would say, there's technical problems with scale, and each one of these architectures scales differently, and everyone has their argument for why that's not so, and it won't work that way. But there's about some of these technologies. One of the limitations will be, the market will have to consolidate. The technologies will have to consolidate somewhat. So there's kind of these market limitations. On the policy limitations, we just had a panel up here talking about like, oh no, Q day, scary, right? And I have news for you. Security will change more in the next 5 years than has changed its entire existence. I used to work in security. You won't have an application store. You'll have a phone and you say, hey, mail my wife and do this thing and research this thing or whatever. And that software will be written in that exact moment in time. It will finish its execution time and it'll be deleted. So the attack surface will change. Quantum networking will make it harder for you to peer in on other people's messages. So security is going to fundamentally change a lot. So I don't worry too much about that. But I worry about the implications of what we're saying in front of policymakers. I did not go to the White House twice when a bunch of quantum leaders went there because I knew it was going to be a security-focused fear. And I knew at the back of the room would be somebody from the Commerce Department that says, maybe we should block that import-export law, right? Maybe we should write this new policy.
Yeah.
And they're writing it from a position of this kind of fear and uncertainty and doubt that was being used to raise money. And that's a really bad mix. So, there's the technological stuff, there's the policy stuff, but then there's just the adoption stuff. People don't buy what they don't understand. And if you need to have a physicist to run a computer, you have a total enterprise addressable market of 0. Okay? Those are facts, right? And so, we've got kind of some technological stuff on the scaling that has to be fixed. I think, we always say we get to 100 qubits, the world changes. We should make sure whenever you hear anybody say that, you say 100 logical qubits, which is maybe a 1 to 125 with physical or 1 to 500 or whatever. But we'll fix those problems. The policy problems will be damning. I mean, we already see countries seeing this as whenever a country says it's a national security concern, we should all be worried about the advancement of the technology. But the really big thing is if we don't get people adopting it, and I mean, putting it into production, right, then that's going to be the big failure on our part. And then that requires education, that requires access, it requires us simplifying things. We're a software company. My background is in software. It's not in quantum mechanics or quantum physics or anything. Software has one sole purpose in its entire life, and that is the elimination of complexity. And so when I sold my last company, I was looking at what to do next. Many, many years ago, I thought quantum is infinitely complex. And so this is an ultimate kind of like software project, right? But I think all of those things come into play. The one that we ironically can influence the most with our voice is policy, and it's the one we probably influence in the wrong way.
That's a really interesting way of looking at it. And I think the point you made about we don't buy what we don't understand is really important because that then feeds into the policy side of it as well, right? If we're not adopting it,
that's right.
we don't understand it, we're not adopting it, we can't build the right policies.
Fear and uncertainty and doubt are horrible, horrible motivators for policy people.
Well, we only have just about 1 minute left, and I do just want to see if there are any questions in the audience for Worley. We can take
There's not.
One.
No, sorry.
Any questions? I think we have time for about one. Yes, Christina.
I can hear you. I don't think everybody else can.
My question is fairly simple. So do you think we can use any part of the quantum technology to fast track another really important technology called nuclear fusion to make it commercially available soon? Thank you.
So that's a very simple one because I have no idea. I have talked to General Catalyst and Commonwealth Fusion and a bunch of these companies that have approached and asked that. But I think we can use quantum computing and agentic services to accelerate a lot of science. And I wouldn't see why fusion would be any different. We might accelerate them to an end where we find out, we're right. That is a pipe dream, though, right? That might not necessarily get to an answer that you want, but I think we can accelerate all scientific paths.
Perfect. Thank you so much, Rolly. On that note, I think that brings us to the end of our conversation.
Well, thank you for having me.
Thank you so much for coming and joining me today.
Thank you.